works. That's a good sign. Multiply means, no, product means multiply. And quotient means divide. Cool. So when you see those words, that's what it's talking about. Quotient, dividing, product, multiplying. Usually the ones people forget, honestly, are difference. People forget difference means subtract. And quotient meaning divide. Those are probably the two they're just kind of like forgot about for whatever reason. What we're going to do is we're going to like add and subtract functions. So instead of just adding and subtracting numbers or variables, we're going to take an entire function, we're going to add another entire function and then see what happens. So looking at it, like you could imagine that this function, y equals x squared plus x minus 6, you could imagine it as like three little things. And like, what if these were all separate functions? Now imagine this thing was its own function. And this thing was its own function. I don't know if I'm using the same letters as them, hopefully. And this was its own function. Then really I could just be like y equals f of x plus g of x minus h of x. Right? If each thing had been its own function, its own equation. That's essentially what we're going to be doing. We're just going to be taking functions and adding them so that it becomes one function like that. I think they wrote that out there on the left. Did I use the same letters? Oh, crushed it. Right? So if you imagine if f of x was x squared, g of x was x, and h of x was 6, then I could really just say that this is f of x plus g of x minus h of x. And functions being added and subtracted together. It would be this right here. Right? Same thing.
So anytime you see a squared x, that's a function?
No, like this is just an example of like how you could see what it's coming from. You'll see more problems. Like anytime you see an x squared, it just means that it's a quadratic term. I'm not saying it has to be that function. But I'm just showing you how you could take something and break it into parts, right? Cool. Those are the 4 things that we're going to do today. There is another one that we'll do tomorrow. But these are like the 4 basic ones. So again, sum is adding, difference is subtracting, product is multiplying, quotient is dividing. I think these are actually on your formula sheet. Why did I say that without knowing for sure?
Can we add our formula sheet sucks?
Your formula sheet sucks. No, it's way more basic than that. Like if you look, when you see this terminology, you see f plus g of x. That's the same thing as just saying f of x plus g of x. It's no more complex than just like adding. There's no crazy law to it. Like if you wrote it as subtraction, so f minus g of x is the same thing as saying f of x minus g of x. That's why I thought it was going to be on your formula sheet because it's such a basic thing that it really wouldn't help you that much.
Are you saying that the only things I get are
a lot of the time, it's either really complex or really basic stuff on there.
Physics, they give you everything.
Yeah. Physics is loaded. Nothing. Look at this one. So this would be f times g of x. That's the same thing as saying f of x times g of x. And the last one, this would be f divided by g of x is the same thing as saying f divided by g of x.
Will we ever have to solve for x?
Yeah, I mean, we're going to get there. Okay. Like, you'll see.
I thought we could remove the x from the...
Right, but we're going to have actual things for these functions.
Oh.
Yeah. There is something important to note, which is when you do that division one, you have to have this rule on it, where g of x can't equal 0. Why would that be a rule? Can't divide by 0, correct. And we learned that in math 20-1, right? Like you can't divide by 0. You actually learned that in like grade 3. But we then did it in grade 11 when we talked about functions. You can't divide by functions that equal 0. When you do divide by a function that equals 0, it created something. Anybody remember what happens when you do divide by 0?
Oh, it's an error because it's not possible.
Yeah, it would create an error in your calculator. Visually on a graph, it would do something. You're kind of on the right track. You're kind of on the right track with a whole that's more calculus stuff.
This is what I think.
Pardon?
Is there a gap?
There is a gap. There's a word that we need. When you divide by 0, you create an asymptote. Right? So remember in our rational expressions unit last year, when we would have those non-permissible values, which is what a lot of you were saying, visually when you graph them, we did dotted lines and we said that is an NPV because you can't possibly be at that moment. Otherwise, you would be divided by 0, which is not allowed. So it's probably just a good little review to be like, oh yeah, okay, on graphs, it creates an NPV, which means it's an asymptote. More specifically, it is a vertical asymptote. I just put asymptote though. Perfect. Those are all the different types of functions that you have seen at some point or another. Linear is like straight line. Quadratic is the one thing. Radicals, we've done that. It's like the curve. Rationals we did last year. So that kind of creates all kinds of crazy stuff. Absolute values are those like V graphs. Cubics make like a double turn. Exponential and logs we did this year. So it's like the curve and then the really big steep curve. So those are all different types of functions that we technically could add, subtract, divide, or multiply together because those are all the functions we know, right? Let's see what this actually looks like. So it says, consider the function f of x equals x squared, x cubed minus 2x squared plus 6, and g of x, which is x cubed minus 2x plus 6. Determine an expression for, let's talk about that for a second. Determine, that word means like find, essentially, or create an expression. Okay, expressions are not like x equals 6. That would be an equation. We want an expression, meaning there's no equal sign in it. Right? If I did this, x squared plus 6x plus 4, that's an expression. There's no equal sign. Bueno? So our answer is going to be something like that. It's just going to be terms and variables and coefficients and constants. No equal sign, no solving involved. We want to find an expression for this. F of x plus g of x. Hey, you just got to do what it says. So it's saying take f of x. F of x is all of this. And add g of x. G of x is all of this. So it would look like this. X cubed minus 2x squared plus 6. There's my f of x. Plus g of x. G of x is x cubed minus 2x plus 6. Yep.
Is it like f or f like x? Isn't that 2 dot?
My bad. Yeah, thank you.
So like in a situation like this, since in the second, well, g of x, there isn't a x squared, is it valuable to write in like 0x squared?
If you wanted to, you could. It wouldn't hurt. Because when you come to your collecting like terms, it might just be nice to be like, okay, there was no x squareds over there. But we don't need to. That kind of helped us with our systems of equation stuff when we were trying to do like elimination and things like that. But it shouldn't be too necessary here. Okay, that is an expression for f of x plus g of x. No, it's not a simplified expression, but it is an expression. To make it a simplified expression, just actually add the things together. So like terms go together, right? X cubed plus x cubed would become 2x cubed. Negative 2x squared would add with other x squareds. There are no other x squared. So it stays negative 2x squared. X to the power of 1, right? There's only one of them. It's negative 2x to the power of 1. And then constants, meaning that there's no x, go together. Plus 6 more is plus 12. That is an expression for f of x plus g of x.
Do you want us to take out like 2?
No, like you could factor that. You don't need to. You can just say like that. If you factored it, took a 2 out, you're not wrong. You're just doing another version of that same expression. Right? Like they all mean the same thing, just different forms. We would refer to that as simplified form. If it said create a simplified expression, that's a simplified expression.
So like simplified doesn't need to be
Factored. No. It might be. Like they're kind of interchangeable, but usually you would say factored expression. It's not terrible, right? Yeah, not terrible. Okay, let's look at what this means. Okay, so this says f of x plus g of x, right? When we see this, f plus g. Agreed? Normally there'd be an x there, but there's not. What they put was a negative 2. So they're saying x equals negative 2. I could rewrite this to look like this, and I think it's a little bit nicer. I could say f of negative 2 plus g of negative 2. Instead of f of x plus g of x, I'm saying f when x equals negative 2 plus g when x equals negative 2. So what I would do is I would calculate each one of these individually. I would go and I would figure out what does f at negative 2 equal. So go to your function. Where can I write? I can write this here. I believe fx equaled, it was x cubed, right? Minus 2x squared plus 6. Okay, so go ahead and change that to be f of negative 2. So it's now negative 2 cubed minus 2 at negative 2 squared plus 6. You put that into your calculator. Negative 2 cubed. Make sure you use brackets when you're doing negatives squared and cubed because it does make a difference. Negative 2 cubed would be negative 8. And then you're going to subtract 8 more. And then you're going to add 6. And you should get that f of negative 2 equals negative 10. Make sure you use brackets. And just be very cautious because that negative 2 squared is actually positive 4. If you don't put brackets, your calculator will screw that up. So make sure you put brackets when you're calculating. Okay, that means, back to my original question, I have negative 10 plus. Now figure out what g of negative 2 would equal. G of x was equal to x cubed minus 2x plus 6. go ahead and change the x to be -2. And you end up with -2 cubed minus 2 times -2 plus 6. Throw that in your calculator. And you should find that g of -2 equals 18. Is that right? -8. No, sorry, that is not right. Yeah, sorry, my bad. Is 2. It'd be -8 plus 10, which is +2.
Oh my gosh. I wrote 16 minus 6.
That would be one. Back to the original question. That means this is 2. So really what they're asking you was -10 plus 2. The answer would be -8. Right? It's like understanding what this notation means. This means figure what f equals at -2 plus whatever g equals at -2. You go to your equations, you change x to be -2, you calculate, change x to be -2, you calculate, and then you add those two values together. Yeah, man.
You could also just use the equation you found above, right?
Yes. So there's a second strategy to this. The second strategy would be to actually add the functions together and then change x to be -2. Now, normally, on a normal question, that's usually the slower process. However, we already calculated up here what f of x plus g of x was. So you could take that function and change it to be -2. So if you did that, you would get 2 times -2 cubed minus 2 times -2 squared minus 2 times -2 plus 12. If you put that in your calculator, you find
Either you're not writing where we are.
you can't see what I'm doing. It'll come back. Hopefully. If not, this is just for you, Merrick. You should find that it equals -8. Let's see if I can cast and uncast and see if that helps. Yeah. Right, so you could have just done it like that. And you could have figured out what the two things added together is, and then you could have just changed that to be -2. Since we had already done that, that's actually not a bad strategy. On a regular question, I think that's a little bit more complex, like more prone to error. So I would probably just not do it like that. On a regular question. How do we feel about that? A little bit harder, right? Okay, looking at this, f minus g of root 6. What's that actually asking you to do?
Substitute x in for like 6 square root.
Yeah, they're asking you to go change x to be root 6 in both equations and then subtract them. Like that's what it's asking you to do. In this case, we don't know what f minus g of x equals yet. So it might be easier to go ahead and actually calculate each one individually. The problem will come, you don't want decimals. Okay, so don't be actually calculating the root 6. So you don't want to change things to decimals unless it specifically says like round your answer to the nearest tenth. You want exact values. Typically, it should work out decent for you. So if we try it, like f of f of root 6. would be root 6 cubed, right? Minus 2, and then root 6 squared. And then plus 6. Agreed? Okay? You can calculate parts of that, but not all of it. The root 6 cubed, I can't calculate. So I'm going to leave that as root 6 cubed. I'll let the brackets go away. The next term I can calculate. The reason I can calculate is because the square root will cancel out with the square. Right, like that square and that square root will cancel out. So it's really just 2 times 6. So that's negative 12. Plus 6. F of root 6 equals root 6 cubed minus 6. That would be my exact value for f of root 6.
Just a reminder, makers, there is Panicle Pizza for sale at the canteen. Panicle Pizza and a pop for $4.
Then I want to figure out what g of root 6 would be. So do the same process. G of root 6 would be root 6 cubed minus 2 times root 6 plus 6. I believe I have those numbers right. Yeah, it was x cubed minus 2x plus 6. Again, we can simplify certain parts of that. Actually, you can't simplify any of that. The only thing I'm going to do is I'm going to get rid of the brackets. So it would look like this. That's root 6 cubed. So those brackets are gone. Minus 2 root 6. Don't need those brackets anymore. Those brackets just meant multiply, which is what I'm doing. And then plus 6. So substitute that into what it's asked you to do. Right, so I took my equation, I put it into g of root 6. This is an expression for f of root 6 minus g of root 6. But it is not a simplified expression. Right? I can simplify this by actually doing the subtraction of these two things. The trick with subtracting is people forget to put brackets. If you don't put brackets here, then you usually make the error of forgetting to subtract everything. So make sure that this subtraction sign goes to everything in the blue. So it looks like this. It goes in here, in here, in here. I now have root 6 cubed minus 6 minus root 6 cubed plus 2 root 6 minus 12. The first one didn't change, so the purple one stayed. Root 6 cubed minus 6. The blue one changed, so all the symbols changed. Negatives became positives, positives became negatives. And I do have some like terms, which will make this look a little nicer. Root 6 cubed minus root 6 cubed would equal 0. All right, so no need to write those anymore. Minus 6 minus 12 could go together. And the 2 root 6 would be by itself. My answer would be 2 root 6 minus 18. And that's as an exact value.
I'm sorry, this is a stupid question, but where did we get the 12 from?
It's not a stupid question because it should be 12. Should have been a minus 6. Thank you. It's not a stupid question. I just had a typo. It's a very good question. And then the answer is 12. I was ahead. So -6 minus 6 is -12. I saw those look in your eyes, so I knew something was wrong. Nobody would say it. And I have like 14 people looking at me like this. Like, what? Something's wrong. Nobody will say it. The idea behind what we're doing, like this function operations on functions, isn't that difficult. The math can be, right? It's just being very careful, showing your work, like taking your time, don't rush things. But the actual process wasn't that terrible. We substituted root 6 into two things. We simplified them. We subtracted them. Yes, sir.
I have a question. Why couldn't we just take the original equations and then just
Subtract them.
what it is before you substitute them?
You could. Yeah, 100%.
It's so much faster. You don't have to do all that.
Yep. Yeah, like if you would rather take the functions and subtract them and then put root 6 in, you should get the exact same answer. They should work perfectly.
3 steps.
Yeah. As long as you're comfortable subtracting those, you should be fine. And that's actually not a bad subtraction by any means. Like it's pretty straightforward. So you could definitely do that. All right. Doing it with graphs. So you got the function y equals f of x and y equals g of x are shown below. So this one right here, yeah, that's f of x. And this one over here, that's y equals g of x. It does say it at the bottom of the graph, but I just want to make sure that you are on the same page that I am on. All right, let's, I believe, subtract them, yeah. Sketch the function h of x equals f of x minus g of x. All right, back to our old Math 10C. When you saw function notation in Math 10C, you probably had a teacher at some point say this. Y equals f of x. You probably heard that lots. They're the same thing. Remember, we used to literally just change f of x's to be y's. So we'd make equations and we'd be like, just change f of x to be y. Make things simple, just change it. And we're like, y is f of x. It's the same thing. So now, when we're looking at this stuff, and we're like, h of x equals f of x minus g of x, they are talking about y values. They're saying take the y values of f of x, subtract the subtract the y values of g of x. When you do that, you're going to subtract the y values. Subtract the y values when they have the same x values. So for instance, if I look at my two graphs, f of x on the left, g of x on the right, this point right here, and this point right here. On f of x, that is -2, 4. On g of x, that is negative 2, comma 4. Those have the same x value. So if I wanted to find my new point, I would subtract those y values. So 4 minus 4 would be 0. That point would now be at negative 2, comma 0, right there. The x value doesn't change. The y values change. X is negative 2, x is negative 2. Take the y values and subtract them. That's what it asked me to do. So now when x equals negative 2, y would be at 0.
I've just been advised that there is a truck parked in the emergency lane by the student parking lot. There's a truck parked in the emergency lane out by the student parking lot. If that is your truck, please move it immediately.
So go find more points where these have the same x value. Like for instance, this point is at 0, comma 4. This point over here is at 0, comma 4. So I could subtract those 2 points by subtracting their y values.
I think it's frozen.
Yeah, it's definitely frozen. Zero, comma 4, 0, comma 4. Subtract the y values. My new point would still be at 0, and then comma 4 minus 4, which should be 0, comma 0. You could also do the point in between them. You're going to notice that it's negative 1 and 4. So it's going to go to 0, comma 4 again, just like or negative 1, comma 0, just like the other ones. I'm just going to connect a straight line between them.
Wait, and do you always subtract with it from this graph?
Always left to right, because it asked me to do f of x minus g of x. They could flip it, and then you'd have to do the right minus the left. But they specifically said take the y values of f of x, subtract the y values of g of x.